Hello, good morning everyone. In the previous class, we already discussed on the many topics like Gauss law, Coulomb's law, Gauss theorems, and electric fields lines. So here today we are going to discuss on the one new topics, which is mechanical force on the charge conductor. So here there is a term charge conductor. We in the previous class we already discussed and learned many things about the conductor. There are many basic things which I am going to recall you. So because it will help in these topics, like this is a spherical charge conductor. Like so its properties that when we will give a charge to it, then the charge resides on the outer surface of the conductor. Like when we will give any charge like positive, it will resides on its surface, right? And the electric field we already studied. In electric field just outside the conductor is what? Sigma upon epsilon naught, and the electric field inside the conductor is 0, right? So these are the basic things which we already discussed in the previous class, right? And what is the nature of the same charges or the same nature charges? Like when we are talking about the same charges, it will repel each other, okay, like this. So here we can see that here we considered a spherical conductor on which charge reside on its surface. So these all charge repel each other. Due to the repulsion, these all charge repel each other, and due to the repulsion, this conductor feel stress and it's stressed out, okay. So let consider so let's take a element. Let's take a element here, right, which we can say that it is a dA. Let us take an element dA, right? And we already know that any charge feel forces, experience forces due to the electric field of the other charges, not by his own electric field, right? So it's there will be here some charges which feel forced, okay, due to the other charge and present on the surface of the conductor, right? So this is a element dA, right? So here take a point P, and just we discussed about a conductor, but the electric field just outside the conductor is sigma upon epsilon naught, right? And inside the conductor electric field is 0, okay. So here we already taken a element, and the electric field due to this small element is right here, E1 is in the direction, in this direction, right? Because we know that electric field due to the positive charge is away from it, right? Like this, sorry, like this, right? So the electric field due to this small element will be away from it and in this direction, right? So here, and here due to the other charges which is on the surface of the conductor, that electric field will be in this direction. This is E2, and it is also in the direction of E1, okay, right? Because positive charge, electric field due to positive charge is away from it, okay, right? and electric field due to this charge inside the conductor will be like here E1, and now due to these all charge, what will be the electric field? So let's see here. First, here we consider a element, right? Let's divide it into three region. Okay, so electric field due to the charges in this region and this region, which will cancel out. Okay, it's due to the electric field due to the these charges and these charges, it will be cancelled out, because like its electric field will like this, right, and this, and here electric field due to these charges will be like this and this, right? So it will cancelled out. Okay, and only electric field due to the this region will be remain. Okay, so due to the this region electric field will like here E2. So we already know that electric field inside the conductor is 0. So when it will be become 0? When magnitude of this electric field and this electric field will be same, right? So we can write here E1 minus E2 equal to 0, right? So but E1 is equal to E2. So here is a one condition, it's 1. Here E1 is equal to E2. So let's write force experienced by these elements due to the other charges, right? So what will be the force? We know that now force is F is equal to Q into E, right? So here what will be key here? We know now the charges present on this element will be dq, right? Dq. So here dq and what is electric field? So okay, sorry. So here dq and electric field will be dq and E. So what will be E? Here this electric field just outside. Okay. Electric field just outside the conductor will be what? Right, E net will be what? E1 plus E2. And here we already discussed now, just outside the conductor the electric field is sigma upon epsilon naught, right? And here E1 is here the condition, from this condition here E1 is equal to E2, right? So we can write here E1 as we can replace by E2, because E1 and E2 are of equal magnitude. So E2 plus E2, it will be what? 2E2, right? So E2 will be what? Sigma upon 2 epsilon naught, right? So here to find the force experienced by this element will be what? Here dq, here dq, and what? E is E2. Because why I am writing in there E2? Because any particle or any charge experience force due to the other charge and due to the other electric fields, okay, not by their own electric fields. That's why I write here E2, because E2 the electric field due to the other charges. Okay, so here dq, what will be dq? Dq will be we know now sigma into what? Area. What is that area? dA, right? dA. And what is electric field? E2. Here is E2, right? So E2 is sigma upon 2 epsilon naught. right? So what it will be, sigma square, right, upon 2 epsilon naught into dA, right? So right, so here sigma square upon 2 epsilon naught into dA, right? Details let's due to but when we bring it here means force per unit area, right? Force per unit area is what, sigma square upon epsilon naught. Then what it will be, it will be pressure, P is equal to sigma square upon epsilon naught. And we already discussed now, when these all charges which present on the surface of the conductor will repel, because these are in the same nature, so these all will repel each other, due to which pressure is developed and its conductor feel stress and is stressed out. Okay, so that pressure is this, the pressure which is experienced by these element is that, right? Experienced by that conductor is this, right? So here P is pressure and sigma is what? Sigma is charge per unit area, right? Which is basically called charge density. And what is epsilon naught? Epsilon naught is permittivity of free space, right? Permittivity of free space, and its value is what? What is value? What is the value of epsilon naught? Tell me. So value of epsilon naught will be 8.85 into 10 to the power minus 12, right? So here we can, here what our result, sigma square upon 2 epsilon naught. We saw here pressure is equal to sigma square upon 2 epsilon naught, right? So we can also write it in the form of electric field, right? What was electric field just outside the conductor? It was equal to sigma upon epsilon naught, right? So we can write rho as what, electric field into epsilon naught, right? So just put it in this value, right? So here it will be P is equal to what, rho is sigma square, sorry, sigma square. So E upon E into epsilon naught whole square upon 2 epsilon naught, right? So it will cancel, and what will be E square epsilon naught 1 by 2, right? This will be P is equal to 1 by 2 into E square into epsilon naught, right? So that was all about it, mechanical force.